Okay, before we get to the mole equation here, one other thing. Okay, this weekend I had several emails. I don't remember if it was anyone from this class now or not, but I had several emails from people who were requesting permission to see the data for the lab. If you ever have to ask for permission to see one of the files that I have put on Google Classroom, it is because you are not signed in with your school Gmail account. Okay? If it ever, because you already have permission. If you're signed in with your username at isidore.redeemer.ab.ca, that's you already have permission. But if you are signed in with your own personal Gmail account, it won't work because you're not part of the Google Apps for Education group. Okay? And as a result, it looks at you like it would any outsider, and it says, well, he didn't say you could look at it, because I didn't. Okay? So if it ever says you need permission to view this, check and see who you're logged in as. You're probably logged in as yourself, but not your school self. Okay? Because if you're like me, you've got like 4 different Google identities. Okay? So yeah, you probably just aren't logged in with the right identity. So if it does ever ask you that, that's how you fix it. Okay? All right, so for today, we are looking at the mole equation. This is the last thing. Okay, last thing in this unit. So this week, Monday, Tuesday, Wednesday, Thursday, this is what we're going to be working on. All right, this is very much a skill-based concept. All right, so it's going to require some practice. That's why we're spending 4 class periods on it. It also involves, dun dun dun, math, just a little bit. Okay, just a little bit. You have to do some algebra. All right, that's when you move things around in an equation. Right? Yeah, you have to do a little bit of that. It's real easy. Okay, I'll show you how to do it. It's real easy. And then each day this week, I'm going to do 4 examples, okay, to start the class of the mole equation. There's only 4 ways I can ask a mole equation question, and every day this week I will go over each one. So would it be a good idea to maybe watch that at some point in your preparation for your exam? Yes. Okay, because guys, there's only 4 ways I can ask a mole equation question. Okay, so really, if you know all 4 of them, you can't go wrong on the exam. All right. Okay, so the idea here is, okay, are the key points for today. Understand that the mole is a unit for measuring the number of particles. That could be atoms if we're talking about an element, or it could be molecules if we're talking about a compound. All right. The reason we use the mole is because otherwise we're writing absolutely gigantic numbers all the time. Okay? If we're trying to communicate to somebody, you know, that how many atoms there were in, let's say, a glass of water. Is it a big number? It's huge. Okay? It's huge because atoms are incredibly small. So it's not really effective to communicate that way. So we have a number that represents, or sorry, a unit that represents a very large number. Right? Now, do we have other examples of that we maybe use in daily life? A word or a unit that represents a number of something? Okay, meters represents, it's a unit, you're right, it represents 1,000 millimeters, 100 centimeters, 10 decimeters. Okay, I was actually thinking of something else. Sometimes you buy donuts in groups of these. Dozens, right? What number does a dozen represent? 12. We all know that, right? Well, a mole works the same way. Okay, a mole represents a certain number of particles. All right, and so it's easier to say a mole than it is to say this. 2, 3. Yeah? Way easier to say 1 mole than to write that. I'd run out of room. And I even made my marker smaller last week. Okay, still ran out of room. All right, so it's a big number. Okay, it's a big number. A mole represents, okay, a very, very large number of particles. Okay, so it's just for ease of communication. That's the reason we have the mole. All right. We're going to look at the relationship between moles, mass, and molar mass. That's the mole equation. That's the little bit of algebra that we're going to work on. Okay, and then use that equation to solve problems. Okay, they're quite easy problems once we get into them and you see how they work. Okay, you'll see that they are quite easy. Okay, so we can express the amount we have of something in a few ways. We can say we have this many grams of it. Okay, or we can say there's this many particles of it, or more often than not, how many moles there are. Okay, and in this in a balanced equation, those coefficients that we put in represent moles. Okay, so if we have, let's say like this, okay, H2 plus O2 gives H2O, okay, and when we do that, right, we have to put a 2 in front of this, okay, and a 2 in front of this to make it work. That means I need 2 moles of hydrogen to react with how many moles of oxygen? 1, okay, and that's going to make 2 moles of water, all right? So that coefficient can represent number of moles. Everyone all right with that? Okay. Now, we can also use liters, we can use tons. I mean, if it's a fluid or a gas, okay, we can use liters, we can use tons, okay, we can use molecules, doesn't really matter, okay, but moles tends to be the one that chemists use most often, right? And that's because we can't possibly count the number of atoms there are in something, okay? Only recently have we even had the technology to magnify something large enough to even start to discern an individual atom. Okay, because atoms are so incredibly small, right? Only the most modern, most powerful microscopes are actually able to resolve an atom, right? And those atoms are usually large ones, not small ones. Right? So they are very, very small, and as a result, any significant number of them would be nearly impossible to count. All right, so in the same way that a dozen represents 12, a mole represents this: 6.02 times 10 to the 23 particles of a material. All right. If we're talking about sodium, okay, it would be atoms of sodium. Okay. If we were talking about water, it would be molecules of water. It's always the number of the smallest particle. Okay. Now, this number is Avogadro's number. It's Avogadro's number because the guy named Avogadro is the one who came up with the idea. Okay? He's also the one who picked the number. And I don't mean picked it like he just picked it out of his head. He actually came up with this number based on hydrogen. Right? He wanted to come up with a number that represented a fixed number of atoms, but he wanted it to make sense. And I know you're probably looking at that number and going, then why didn't he pick 2? Okay? Well, there's a reason, actually. He said, I'm going to start with the simplest atom that exists, and that's hydrogen. It's got 1 proton, it's got 1 electron. It's very, very simple. He said, I'm going to figure out how many atoms there are in 1 gram of hydrogen, and that's going to be my number that we'll use to represent 1 mole. Okay? Now you'll see why he picked mole for the unit when you see his picture. He looks like a mole. Okay? But, all right. Anyway, he picked this, or he arrived at this because, okay, he took 1 gram of hydrogen and figured out how many atoms there would be in there. All right? Now, he knew the mass of a proton approximately, okay, knew the mass of an electron approximately, added those together, that's the mass of 1 atom. It's an incredibly small number. Okay? Divided that, okay, took 1 gram, divided it by that number, and lo and behold, he gets that there's 6.02 times 10 to the 23, okay, atoms of hydrogen in 1 gram. Okay? So that's where all this comes from. Now, if you look on your periodic table, okay, you can see he was actually off just the slightest amount. All right? The molar mass for hydrogen is actually 1.01, okay, or 1.00794. Right? At his time, the mass of the proton and the mass of the electron weren't known exactly. He was pretty close. Right? So the number you see on your periodic table, if everyone can take theirs out, okay, the atomic mass, it's the number in the top right-hand corner. Okay, that is the mass of 6.02 times 10 to the 23 atoms of that material. All right, so for hydrogen, when I have 6.02 times 10 to the 23 atoms of hydrogen, I have 1 gram of hydrogen. Okay, if I'm looking at lead, okay, lead, if I have 6.02 times 10 to the 23 or atoms of it, I'll have 207.2 grams. Okay, because lead, is its atoms a lot bigger? Yeah, lead atoms are way bigger, right? They've got 82 protons instead of 1, right? That kind of makes them a lot bigger. All right, so each atom on the periodic table, okay, the atomic mass is the mass of 1 mole of that material. All right, everybody okay with that? Okay. All right, questions here? All right, so the mole represents a fixed number, in this case, Avogadro's number, 6.02. You're not going to have to memorize that number, although you probably will indirectly. It'll always be given to you, okay, on your exam quizzes, things like that. All right, so the mass of 1 mole of a substance is known as that substance's molar mass. Okay, when we're talking about elements, we call it atomic mass, but it's essentially the same thing as the mass of 1 mole. What if I want to calculate the mass of a compound that's made up of more than one atom? What'll I do then? And then add them. Okay, what if it's something like, let's say, water? How am I going to do that? Right. Plus 1 oxygen, right? I have to take into account how much of everything there is in the atom. Okay, so the example we have here is for water. There's 2 hydrogens, and each hydrogen, if I have 1 mole of each hydrogen, is 1.01 grams per mole. Okay, and there's 2 of them, so I multiply it by 2. Okay, and each oxygen, if I have a mole of oxygen, that's 16 grams of oxygen. So if I add that together, okay, I'll have 2.02 plus 16, and that gives me 18.02 grams per mole. Okay, everyone follow my calculation there? Right? What if I have instead, let's say, that stuff? Yeah. Same process? Yeah, it's still the same process. How many lithium are there? 2. Okay, so the molar mass of lithium is 6.94 grams per mole. Okay, you can double check it, but I'm pretty sure that's what it is. Okay, so 6.94 grams per mole for my lithium. And how many lithium are there? 2. All right, so I go 6.94 times 2. That takes care of my lithium. Okay, what else do I have in there? Sulfur. How many sulfur do I have? 1. Okay, and for sulfur, we're looking at 30.98. 32.07. Okay, and then how many oxygen do I have? 4. All right, so then I've got to go oxygen, which is 16, times 4. Okay, if I add that all together, will I have the mass of 1 mole of lithium sulfate? Yes, it will. All right, so being able to read a compound, okay, read its formula and know, okay, there's 4 of this, there's 1 of that, and there's 2 of that is important. Otherwise, you're not going to get the molar mass correct. Okay, the place where this messes with people the most is if I ask them this question, but instead I write it like this. Why does that mess people up? They'll get it right if I write it Li2SO4. Why will they get it wrong if I write it like that? Right, because it's in word form. What will they forget to do? Yep, that's exactly what they'll forget to do. They'll forget to swap and drop. Okay, they'll look at this and they'll be thinking mole equation, mole equation, mole equation, and they'll go LiSO4. They're not going to get it right now because they're going to miss 1 lithium. Okay, so we got to make sure we remember to swap and drop when we're writing the formulas for ionic compounds. Okay. All right. I would like you guys, using your periodic table right now, to calculate the molar mass of those 5 compounds. Okay, I'll give you a few minutes, and then we'll go through them together. There's an extra up here. All right, let's just look at the first 2 here. Okay, just to make sure we're all on the right track. Okay, I want to find out the molar mass of the following compounds. So, sodium chloride. How many sodium are there? 1. Okay, so I look up sodium on the periodic table as 22.99. Okay, and then I add that to how many chlorine? 1. Okay, so 35.45. Okay, is chlorine. So I add those 2 together. Okay, and I should have 58.44. Is that right? Okay, and what are my units? Actually, not moles, grams per mole, right? Okay, because this is the mass of 1 mole, grams per mole. Okay, in terms of units, if you have an answer on an exam or a quiz that requires units and it doesn't have any, is it right or wrong? It's wrong. Yeah, okay? There's no half points for that. An answer without units is meaningless. because I don't know whether it's apples, oranges, old ladies in walkers, elephants on steroids. I don't know. Okay? But you got to put units on there, or I don't know. Okay? And as a result, the number's meaningless. So always make sure you include units on answers that require them. Okay, for number 2, I've got iron 3 bromide. Okay, so for iron, we're looking at, what is it, 58 point something? 55.85, okay. Okay, and there's only one iron, okay, but there's 3 bromine, and bromine's what, 79.90? Okay, so 79.90 times 3, okay, so we want to, I'm not going to do that one in my head. Okay, all right, so we got 55.85, whoop. Okay, plus 79.9 times 3. All right, so we got 295.55. Okay, and that's going to be grams per mole. Okay, how are we doing on those so far? Okay, all right, I'll give you a couple more minutes to finish up these ones. Remember now, when you get down here to the polyatomic ions, and you're looking at these with the brackets, how many nitrogen are there in this compound? 2. How many hydrogen? 8. Things like that are important to be able to do. Okay? All right. All right, let's look at number 3 and number 4 here. Okay, so for number 3, we've got diphosphorous pentaoxide. Okay, so to calculate this one, we need to take phosphorus, which is 30.97, and multiply it by 2. Okay, and add that to 5 oxygens. Okay. Okay, so we got 30.97 times 2 plus 80, right? 16 times 5 is 80. And we'll just put it in. Whoa. Multiply. Yeah, jeez. Okay. 30.97 plus. Okay, 141.94. Okay, should be our molar mass. Okay, for that. Okay, and grams per mole. Okay, for number 4. Okay, for number 4, we said we had 2 nitrogens, so we'll go 14.01 times 2. Okay, and we're going to add that to 8 hydrogens, so I'm just going to put 8.08 there because that's a pretty easy one to do in your head. Okay, and then a sulfur. All right, so we got 32.07 for that. And how many oxygens? 4. Okay, so 16 times 4. So yeah, sometimes you run into a lot of stuff, okay, in a compound. Okay, so we got 28.02. Okay, that's our nitrogens plus 8.08. Okay, there's our hydrogens, our sulfur, okay, and our oxygens. All right, so 132.17 for ammonium sulfate. Okay, how many people have number 5 done? All right. So for number 5, we got scandium carbonate. Scandium is what, 44.96. And there's 2 of them. All right, and then we're going to add that to how many carbons? 3. All right, so we got 12.01 times 3, okay, which is 36.03. And then we've got 6 oxygens. Hey, what did that one come out to? Someone can save me some time. That seems about right. Grams per mole. Okay, is that making sense to people? Being able to do that step is relatively easy, but it is incredibly important because if you don't do that step right, whatever you calculate using the mole equation won't come out right either. Okay. Okay, any questions there? Okay. Now, when we're interpreting chemical equations, we talked about this kind of briefly at the beginning. Not as important for Science 10 as it used to be. Okay. In Science 10, we used to do what's called stoichiometry. Okay, and that meant using how many grams of something you had on the reactant side to figure out how many grams of something else you would have on the product side. Okay, you don't have to do that now. Okay, in Science 10, but you will do it almost the first thing you do in Chem 20. Right, but it's important for us to realize that these coefficients can mean actual atoms. So we could say I have 1 molecule of nitrogen reacting with 3 molecules of hydrogen to produce 2 molecules of nitrogen trihydride. Or it could mean that I have 1 mole of this, okay, 3 moles of that and 2 moles of that, okay, or it could be masses, okay, and I would have 28.02 grams of this, and I would have 6.06 grams of that, and I can't remember what that would come out to, but 28.02 or something like that. Anyway, okay, on the other side. Everyone follow? So that's what those coefficients can mean. That's really about all you need to know about it now for Science 10. All right, so like I said, it could be particles, moles, okay? It could be, there's Avogadro. Yeah. I mean, it's the cut of the suit, right? For some reason, they cut suits differently back then, and it made them look like they had no shoulders and all neck. Okay, yeah, kind of like a mole, you know, because they don't have much shoulders either. They got to dig. Yeah. All right. Now. Okay. Now, the other part we said those numbers could represent moles in a reaction. Okay. It could also be the mass, whatever. All right. Now, when it gets to the mole equation, here's the mole equation. And you have to understand that chemists think different than everybody else. All right. The mole equation is N equals M over M. There's 26 letters in the English alphabet. They have a 3-variable formula. And they used M twice. Okay? 26 letters to choose from. They used M twice. And the only other letter they used is the other letter that sounds like M. So when you say this formula, N equals little m or big M, it all sounds stupid. Okay? I can't help you there. Sorry. Chemists are just different people. Okay? So here's what you have to remember. N stands for the number of moles. Okay, so when you're looking at what everything in this equation stands for, okay, N is the number of moles. Okay, little m is the mass of the material, and that will be in grams. Okay, so this will be in moles. Okay, so N is in moles. Okay, little m will be mass in grams. Okay, and big M is molar mass, that thing we just learned how to calculate. So the capital M is capitalized because it stands for something with 2 M's, I guess. I don't know. However you need to make it work in your head. Okay? So it stands for molar mass. Okay? Big M is the molar mass of the material. Okay? And that's always going to be in grams per mole. All right? So it sort of makes sense. If I take the mass of something and divide by the mass of 1 mole, that should tell me how many moles I have. Agreed? Right? Okay? So, I mean, if it's like, let's say I had, slices and slices per pizza, I'd be able to figure out how many pizzas I had by dividing the number of slices by how many slices are in a regular pizza, and I would figure out how many pizzas I had. It's kind of like that, right? Okay. When you're manipulating an equation, right now it's set up to solve for the number of moles. Right? How would I solve for, let's say, little m? What are we going to do to solve for something that's not being solved for right now? Yes, you're right. The number 1 rule of algebra is, if I want to move something, I do the opposite. What am I doing right now with big M? I'm dividing. So if I want to move it to the other side, which is what I want to do, okay, I want to solve for little m, which means I need to isolate it, that is, get it by itself. Right? So I want to move big M. To move big M, I have to do the opposite of what I'm doing right now. That's the first rule of algebra. Okay? The second rule of algebra is what you do to one side of an equation, you do to the other. And there's another half rule, but I won't teach you that until physics. Okay? For right now, those are the only two rules you need to know. Guys, I'm terrible at math. Okay? Terrible at it, honestly. Okay? And I teach physics. Okay? I teach physics. You don't have to be good at math to do this. All right? This is grade 8 algebra. Okay? That's all you need to be able to do to get through university physics. Okay? Trust me. Okay? It's not going to get you through university math. I found that out the hard way. Okay? Yeah. I got through university calculus by memorizing the examples in the textbook and writing them down on the test and getting part marks per method. I don't recommend that as a way for success for you. It got me through, but okay, I'm not good at math, but I can remember those two rules. Okay, and those two rules can get me through. Okay, if I want to move something, I do the opposite, and what I do to one side, I do to the other. Okay, now I know that some of you are probably thinking, okay, that you want to use something. How many of you are thinking, I'm going to use a triangle? Really? None of you are thinking that? I love you guys. Okay? Because every year somebody goes, I'll just draw a triangle. Okay? If you're thinking that right now and just don't want to admit it, don't admit it. And forget it. Okay? Triangles, guys, are no good. Okay? If you're thinking you could use a triangle for this formula, you're probably right. It'll work for this formula. But triangles are a crutch. Okay? And they only work for this kind of formula. So there's like 3 formulas in your whole life they'll work for. All right? And after that, they're no good. All right? For example, when we get to physics, and you have to use that formula, there's no triangle that'll work there. Okay? A triangle only works if everything is division and multiplication. As soon as you throw something else in there, like subtraction, you're screwed. Okay? So if you really struggle with algebra and you've been riding the triangle horse for a while, you better come in and see me and I'll show you how to get off that horse. Okay? All right. So I want to solve for little m. Okay? So I'm going to multiply both sides by big M. All right? Now, what I really did there, other than kind of that cool moving thing, okay, is I did this. I said I'm dividing by m, so if I want to move it, I do the opposite. So I multiplied both sides by big M. Okay, because that's the second rule, right? Do the opposite, do it to both sides. Now, if I have a big M on the top and a big M on the bottom, what do? They cancel each other out because big M divided by big M is 1, right? Okay, it's not 0. That doesn't work out so well. Okay, but yeah, so it cancels off, okay, and now I've isolated M. And guys, that's the only manipulation of this formula you're ever going to have to do. Because you'll never have to manipulate for big M, because how do you calculate big M? From your periodic table, and you're always going to have that. Okay? So you're never going to have to solve for big M. Just little m or n. Those are the only 2 things you'll ever have to solve for. Okay? So can we all do that manipulation? Yeah, nobody needs a triangle for that. Okay? All right. So we're going to look at, okay, a couple of things here in terms of calculating. So right now, I'm about to go over those 4 ways I can ask you a mole equation. Okay? Here's the first way. Okay. So we're looking for how many moles of calcium chloride are in 90 grams. Whenever you have a problem-solving question in Science 10, the first thing you want to do is write down what the question gives you. We call those givens. Okay? So what has the question told me? Well, it's told me what material I'm dealing with. That'll help me calculate this. Agreed? Okay? So in case it didn't give it to me this way, the first thing I want to do is write the formula out. In this case, it gave it to me, so it's kind of redundant, but that's all right. Okay? What was the other thing it gave me? 90 grams. What part of the mole equation is that? M, little m, right? All right, and it's asking me how many moles. Which part of the equation is that? N. Okay, so I've got to find N. And I have 90 grams, and the ability to calculate big M. So I should probably calculate big M right now. Agreed? Okay. So for calcium, we're looking at a 30.08, right? No, 40.08. 40.08, okay, plus 35.45 times 2, 110.98, right? Yeah. Okay, sorry, I know I told you I was bad at math, and that's just adding. That's not being good at math, that's just adding. Okay. Here, I'll show you how I cheated that one in my head. What's 35 plus 35? 70, okay. 45 times 2 is 90, plus 8 is 98, 110.98. I just shortcut in my head. Okay, yeah, all right. I just make everything a small, easy calculation to do and then fix it all at the end. All right, so now I've got the two numbers, okay, that I need in order to get n. So now I write down the mole equation. N equals little m over big M. I don't have to manipulate. It's already set up to solve for the number of moles. So now I plug in my numbers. Okay, so my mass, 90 grams. Okay, divided by my molar mass, 110.98 grams per mole. Do I have more than 1 mole or less than 1 mole here? Less, yeah. Okay, 90 is less than 110, so I'm going to get a decimal. That's okay. It's all right to have less than a mole. All right, so we got 90, okay, divided by 110.98. All right, so we got 0.812, or sorry, 811 moles. I'd say take it to 3 decimal places for this, okay? We're busy, so we abbreviate moles, okay? We have an abbreviation for everything, right? We're so busy we have an abbreviation for at. Okay, so we have an abbreviation for moles. Okay, did everyone follow what we did there? Okay, here's the marks you would get for this. You get 1 mark for writing down what the question gave you. That's a pretty good deal. Okay, you'll get a mark for choosing the correct formula. Possibly you might have to manipulate that. Okay, sometimes I'll give you a separate mark. If you've had to manipulate, I'll give you another mark for that. Okay, probably on this question I wouldn't give you both of those. Okay, but on a lot of questions I would. Okay, and then obviously 1 for your final answer. Okay, so this would be a 3 or 4 mark question. This one would probably be 3. Okay, unless I was feeling really generous. Okay, now you should be able to get, even if you had no clue what to do after knowing the mole equation and calculating molar mass, did you just get like 50% or more? Yeah. Okay, so just remember those little things, right? Always show something. If you leave something blank, what are you going to get? 0. So always show something. Okay, there's part marks for lots of things, so show as much as you know. All right, questions on that one? Okay, that's the easiest a mole equation question will be, right? Because basically all you do is plug numbers in. Okay, for number 2, what's the mass of 4.5 moles of, now I gave you it in words, magnesium bromide? All right, they told me what the substance is. They told me it's magnesium bromide. So magnesium, 2 plus, bromine, minus 1, so I drop and swap. There's my formula. Can I calculate the molar mass now? Yeah, okay. So for magnesium, we got 24.31. Okay, and we add that to 79.90 times 2. Okay, and we'll get the molar mass there of magnesium bromide. All right, so 184.11 grams per mole. Okay, what else did the question give me? The number of moles, so that's n. Okay, Okay, 4.5 mole. And I'm looking for what is the mass. Okay, well, the mass is little m. Okay. You got 1 mark. Okay. Now we've got to use this. N equals little m over big M. But I'm trying to solve for little m, so what do I have to do with big M? I have to move it to the other side. If I want to move something, I do. Okay, before I do the same to each side, I have to do the opposite, right? So I'm dividing by m, so I multiply by m. Okay, I do that to both sides. Okay, now I've got my formula. That's a mark. Okay, you get a mark for the algebra. All right, you're going to get a mark for now plugging the numbers into the right place. Okay, big M was 184.11. Okay, N was 4.5. Okay, and that equals little m. And that kind of makes sense. If this is the mass of 1 mole, and I have 4.5 of them, multiplying would give me the total mass. Agreed? Okay. All right, so we're going to get 828.50. Okay, or we could write 495, 828.495 grams. Okay, that's definitely a 4-mark question. Okay, questions on how that one works? Okay, now, the next 2 that I'm going to show you have 1 extra step. Okay, that 1 extra step is now going to involve Avogadro's number. Okay, that number we looked at the beginning, 6.02 times 10 to the 23. Okay, that number is now going to come into play because the next 2 types of questions are going to ask for the number of atoms or molecules. Okay, so it may say something like, how many molecules of water are in this many grams? Right, then we'll have to figure out, first off, how many moles there are. And then when we know how many moles there are, we can use Avogadro's number because Avogadro's number is how many there are in 1 mole. All right, so you guys following kind of where we're going there? It's just, this will work like if someone told you you have 48 donuts, how many dozen do you have? 4. Okay, because there's 12 in a dozen. Okay, or if somebody told you you have 36 donuts, or sorry, if someone told you had 3 dozen of something, you would go 3 times 12 and you'd know you had 36 of that. Okay, so that's kind of where we're headed here. Okay, so how many molecules are in 600 grams of silver nitrate? Okay, should we still write down our givens? Yes, we should. Okay, first thing is that we know the mass. Okay, it's 600 grams. Okay, and they told us what material we're dealing with. It's silver nitrate. Okay, so we got silver, which is a +1. Okay, and it's, oh man, it's not right. Okay, NO3, nitrate, that's a -1. All right, so is that okay, that one? Yeah. All right, so we got silver nitrate. We got to figure out how much mass that is. We got 107.67, right? Okay, so that's silver, 107.67. How many nitrogen in here? 1. Okay, so 14.01. Okay, and there's 3 oxygens, so 16 times 3. All right, that's going to give us our total molar mass. Okay, so 107.67 plus 14.01 plus 48. That's 16 times 3. Okay. All right, 169.68. Okay, and that's going to be grams per mole. Okay. I've got little m and I've got big M. What can I calculate with those 2 things? The number of moles. Okay, so even if I really wasn't sure where else to go, that's the next step that I should be able to kind of logically figure out. If I have these 2 things, find what I can find with those 2 things. Okay, the mole equation says little m over big M gives me N. All right, so I'm going to find that next. And even if I don't know where to go from there, at least I did one more step and got another mark. Okay, so our mass was 600 grams. That was given to us in the question, divided by 169.68. Okay, and I think we're looking at, what, 3.83 or something like that? .54. Okay. Okay, so I've got 3.54 moles of silver nitrate. But the question wants to know how many molecules I have. Okay, now I've got to use Avogadro's number. Remembering that Avogadro's number tells me what? Avogadro's number tells me how many particles are in a mole. Okay, it applies to everything. Okay, for every single material you could possibly imagine, there are 6.02 times 10 to the 23 particles in 1 mole. Okay, the mass of that amount will be different for every single thing. Okay, but there's always in a mole 6.02 times 10 to the 23 particles. In the same way that it doesn't matter whether you're counting donuts, eggs, loaves of bread, whatever, a dozen is always how many? 12. Well, a mole is always 6.02 times 10 to the 23. It doesn't matter what you're dealing with. Okay, is everybody clear on that? I have a lot of people who get confused, okay, on that part. 6.02 times 10 to the 23 applies to everything. Okay? All right, so I have this many moles, and in 1 mole, there are 6.02 times 10 to the 23 particles. So what do I have to do with those two numbers to figure out the number of particles? Not divide, multiply, right? Okay, so this is how many moles I have, and I'm going to multiply that. Okay, so to get the number of molecules, I take my moles, N, and I multiply by 6.02 times 10 to the 23. All right, so that's going to mean 3.54 times 6.02 times 10 to the 23. Now, you might be looking at that going, how do I put that in my calculator? That is a good question. I'm going to show you. Okay, if you have a TI, I'll show you how that works, and then I'll tell you how it works on other kinds of calculators. Okay, so on a TI, because I'm assuming a lot of you have that, okay, we're going to take our 3.54, and we're going to multiply it by Avogadro's number. Avogadro's number has to be put in brackets. Okay, it's got to be isolated from everything. So then I type 6.02, and then I hit the second function button. Okay, so I hit second, and then I go down here to where you see the comma. Above the comma are 2 capital letter E's. So you want to press comma. All right, that gives you that little E. That little E stands for times 10. All right, and the next number you enter is the exponent that's on the 10. So that number's got to be 23. Okay, then close it up. That's Avogadro's number on TI. Well, the problem is that oftentimes when people do it any other way, they screw it up. Okay, they always seem to end up somehow multiplying by an extra power of 10. This way, that doesn't happen. Okay? All right, so now I've got that. I can press enter, and there's my answer. I have 2.13 times 10 to the 24 particles, okay, in this case molecules, of silver nitrate. Okay, now, if you have something other than a TI-83, you probably have a button on it that looks like this. Okay, that's your exponent button. So you would type in on your calculator 6.02 and then press this button, and it'll probably give you that E. All right, or it'll have a little times 10 somewhere. Okay, this will show up somewhere on your calculator screen. Then you type in 23. Okay, still needs to be all put in brackets. Okay, no matter what calculator you're using, you got to use brackets, 6.02, okay, press the EXP button. If it doesn't have an EXP button, it probably has a button that looks like this. Okay, that's basically the only three options you're going to have. Okay, if you can't find it on yours, let me know and I can come around and help you find it. All right, so this ended up being, what did we say, 2.14 times 10 to the 24 molecules. Okay, now, for this question here, okay, here's where you get your marks. Okay, first mark there, all right? Second mark here. Okay, third mark there. Fourth mark there. Sometimes I give a fifth mark, okay, depending on, maybe I give a mark for plugging in. Most of the time, this would be a 4-mark question. Okay? Questions there? All right. Last way I can ask you a mole equation question is the reverse of this. Instead of asking you for the number of molecules, I give it to you. Okay? And then I ask you to calculate the mass. All right? So that's the last way it could happen. So what's the mass of this many molecules of this stuff? All right? So essentially, we do the last one backwards. Okay? We start with Avogadro's number, and then we move backwards to the mole equation. All right. So here's what I'm given. First off, I've got the number of molecules. And that's 1.54 times 10 to the 25. Okay? I'm also told the material. Okay, so I can calculate big M, diphosphorous. Okay, tetraiodide is that stuff. Okay, and I don't reduce that because it's molecular. All right, so if I'm calculating molar mass there, we might as well do that while we're looking at it. 30.97 times 2, that's the phosphorus. Okay, and then iodine is big. 126.9, okay, times 4. Okay, so 1 mole of diphosphorous tetraiodide has a molar mass of 569.54 grams per mole. Okay, and that's all I have at this point. So if I know how many molecules I have, and I know how many molecules are in 1 mole, can I figure out how many moles I have? Yeah, in the same way that if I ask you how many dozen you have, if you have 36 donuts, you go 36 divided by 12. Okay, well, I'm going to take this number here and divide it by Avogadro's number because that's how many there are in 1 mole. And that'll tell me the number of moles. All right, so N is going to equal our 1.54 times 10 to the 25 divided by 6.02 times 10 to the 23. Okay, divided by Avogadro's number. This will tell us the number of moles. Okay, so when you do this, both of those numbers have got to be in brackets, okay, because they both have exponents on them. So 1.54, okay, and then I hit the exponent here, so I get the E, okay, 25, okay, divided by Avogadro's number, which also has to be in brackets, 6.02, okay, 23. All right, so I have 25.58 moles of this stuff. So now that I have N and I have big M, can I find little m? Yeah, because now I've got 2 out of the 3 parts of the mole equation. All right, so N equals little m over big M. What do I do with big M? How do I move it over? Multiply it, right. Okay. Now I just got to plug in my numbers. So 25.58 multiplied by our 569.54, okay, which was our big M. Okay, so little m is going to equal okay, 14,569.63 grams. I got mine like a steel trap, just always closed. 63 grams. Okay, this would be a 5-mark question. Okay, here's why. You have a manipulation in this one you didn't have in the last one. So you'd get a mark for your givens, right? You would get a mark for calculating the number of moles. Okay, you'd get a mark for manipulating the equation, all right? And you'd get a mark for plugging in your numbers, and a mark for your answer, 5 marks. Okay, because that one's got the most steps. Okay. Those are the only 4 ways you can be asked to do a mole equation question. All right? And I'm going to start every class this week by going over 4 different ones. Okay? But it's always going to be the same method. There's only 4 ways I can ask a mole equation question. Okay? Everybody with me so far? All right. If you're panicking today, stop panicking. We have all week to work on this. Okay? You're going to have lots of time to ask for help. Okay, so you'll start with this one. Now, just to outline a couple of things here. Okay, how many atoms or molecules are present in each of the following? So, if we're looking for the number of atoms or molecules, okay, we're going to have to use whose number? We're going to have to use Avogadro's number here, okay? And Avogadro's number tells us how many molecules, atoms, particles are in 1 mole. Okay, does it matter what material we're dealing with? It does not. Okay? 1 mole of hydrogen has the same number of particles as 1 mole of oxygen, as 1 mole of nitrogen. Okay, it's all the same. 1 mole is 6.02 times 10 to the 23. Everybody follow me there? Yeah? Okay. So, how many atoms of gold are in 1 mole? Wow, I was really hoping for that answer to be really immediate. No. 6.02 times 10 to the 23. Because that's how many atoms of anything are in 1 mole. Okay? 1 mole is 6.02 times 10 to the 23. If I have 1 mole of anything, that's how much I have. Okay? Now, what if I have 2.5 moles of something? Then I go times 2.5. So I go 6.02 times 2.5. Okay? Did it matter what material I had? Nope, didn't. Didn't make any difference because 1 mole of anything is 6.02. 2.5 moles of anything is 2.5 times 6.02 times 10 to the 23. Okay? Everybody following me here? Okay? A mole is a mole is a mole. Doesn't matter what you're dealing with. Okay? It's always the same number. Okay, when you get down to number 2, now you're going to have to start using the mole equation. Okay, so for number 1, you don't have to use the mole equation. You just have to use Avogadro's number. Okay, for number 2, now you're solving for, how do you say, what's n, right? Okay, number of moles is n. So you're solving for n using what they give you here. They're telling you it's sodium. They're telling you the mass. Okay, we calculate from there. Okay, so we're going to spend some time practicing this stuff. Okay, now the key for this, guys, is on my website, same place, okay, as the reactions key was. Okay, so if you go to Science 10 stuff, okay, and you go to chemistry, it's way down near the bottom. Okay, and it says keys to all mole equation worksheets. That's the one you want. Okay, so you can check them as you go. All right, you still got about 7 or 8 minutes. Okay, so let's get to work on that. Okay, you can get started on that sheet now.